Currently, the only way to get RSiteCatalyst is via GitHub. Using the DevTools package with the install GitHub function will download RSiteCatalyst and install it in your local R environment. In the coming months, RSiteCatalyst will be listed on CRAN. When that is the case, installing RSiteCatalyst would follow the normal package install process. The Adobe SiteCatalyst REST API requires authentication using a username and shared secret. These credentials are different than your regular username to log into SiteCatalyst. In order to have API access, you need to be part of the Web Services Access user group within the SiteCatalyst admin panel. Once a user has been added to the Web Services Access user group, the username and shared secret can be found at the bottom right within the User Management Users tab. Assuming you have the proper credentials, authentication for the RSiteCatalyst package is run once at the start of a session using the scauth function. The scauth function takes two arguments, the first being the username company string, and the second argument is the shared secret. After running the scauth function, you will have a new object in your R workspace called scredentials, which holds all of your information. It is this object that is used by all of the other functions in the package to authenticate every API request you will be making. You can test to make sure your credentials are correct by using the getTokenCount function. If this function returns a valid answer, then you have successfully connected to the SiteCatalyst API. There are 7 functions that provide metadata about a company login and its report suites. These functions can be used as a way to understand what elements are available for querying. As an example, let's run the getAvailableElements function to find out what breakdowns are available. On line 6, you can see the getAvailableElements function with a single report suite, Keystone Randy. And when we run this line of code, we'll get back a data frame that has 3 columns. The first column being the report suite ID, the second column being the element name, and it's the element name that we'll use later to make API calls for analytics. And then third, we have the display name, which is how the value is actually shown within SiteCatalyst. If we wanted to pass multiple report suites to the getAvailableElements function, we could do so using the code on line 7. In this case, it assumes that we have an object called report suites, and from report suites we'll use the RSID column. The way to actually get this list is to use the getReportSuites function, which I'll submit now. The report suites object comes back as a data frame with 2 columns, where the report suite ID is in the first column, and then the site title is in the second column. So now, with the report suites object in place, we can pass an entire list of report suites to the getAvailableElements function, and in this case our elements data frame will go from 89 observations to several thousand. So now you can see we have 3,183 observations. The data frame has the same structure as before. And all of the functions that are listed below have the same basic characteristics. You can pass a single report suite, multiple report suites, or even a list of report suites and get back either the available metrics, evars, segments, events, or traffic variables. A queue overtime report is a report where there are one or more metrics where the only allowable dimension is time. For a single metric, a queue overtime report is the same as running an event report within SiteCatalyst. For multiple metrics, the Q overtime report is the same as running a key metrics report within SiteCatalyst. Here, we have a key metrics report for randyswitch.com for the first 14 days of March. And what we have is 4 metrics here: page views, visits, unique visitors, and bounces. And what I'm going to do next is show you how, using RSiteCatalyst, you can get this same information but within R instead of having to go into SiteCatalyst. Here we have a series of Q overtime API calls that we're going to go through as examples. The first example is the minimum amount of code that you need to make a Q overtime request. For the first request, we're going to use the Keystone Randy report suite. We're going to use a start date of March 1st, 2013, an end date of March 14th, and we're going to get page views. So all we need to do is submit this code. And what we get back is a data frame that has one observation that sums all of the page views for the time period that we requested. And if you remember back just a couple of seconds ago when we were looking at SiteCatalyst, there were 2,121 page views. And of course, this is the desired effect, that we're going to get the same exact numbers using R as we would if we were in SiteCatalyst. Now, the reason why there's no granularity here is because in the first example, we didn't specify a granularity. So in this case, all of the data returns back in one line as the sum across all of the dates. The second request is building upon the first request, where we add additional metrics. So now, instead of just one value for page views, we're passing a character vector of 4 values: page views, visits, visitors monthly, and bounces. And when we submit this, that request, now we're going to get back, again, a data frame with one row that has the sum of page views, visits, monthly unique visitors, and bounces. If we wanted to go a little bit further, we could go ahead and actually specify granularity. So we have our same 4 metrics for the same time period, but instead of having one row, now we're going to get a row for every day in our time period. So we're going to have 14 rows. Okay, so now we have a data frame that is going to match the key metrics report from SiteCatalyst, except for the fact that there's no total value at the bottom of our report. And then finally, we could go through and add additional things such as a segment, but rather than go through that example, I want to move on to a real-world use. So suppose we wanted to create a visualization as a control chart on the number of visits that we have per day, so that we can start to understand when the variation in visits is no longer expected, or it's no longer quote-unquote normal. And we can do this using the QCC library, which more or less stands for the Quality Control Library. And so we can specify that here with the library command. And then we want to train our report, so we're going to use the first 10 days of the month as our sample period of variation. Next, we want to see if days 11 through 14 are actually in statistical control. So we can create another numeric vector for that. And then finally, we can call the QCC command, which is going to create a plot that will show us a control chart. And as you can see, at the bottom right here, we now have a control chart. And so, this is one of the many real-world examples and reasons why you might want to use the SiteCatalyst API through R rather than having to go through SiteCatalyst. SiteCatalyst will likely never have a chart that looks like this, and with a little bit of scripting, you can create an automated process that will create charts like this. A Q-ranked report displays the rankings of a variable relative to a metric. This corresponds to the ranked report type within SiteCatalyst. So for the search keywords natural report that we have here, each search keyword is listed one time in the report, and then they're sorted in descending order by the first metric that's listed, in this case visits. To create the search keywords natural report, we can use the Q-ranked function with the following arguments. First, we're going to specify the report suite. We're going to specify the start and end date. We're going to specify the metrics that we want. And then for the element we want to break the report down by, we're going to use a search engine natural keyword. Finally, the last two arguments that we specify how many results we want back, so up to 100,000. And we want to start with the number 1 so that we get all the search keywords back. And what we get back is a data frame that contains all of our search keywords, and they're sorted in descending order by visits, because that's the first metric that we specified in the function call. The Q-ranked function also supports specifying just the elements that you want from your ranked list instead of using the top function. And the way to do this is by using the selected argument instead of using top and starting with. For a real-world example, suppose we wanted to get a basic visualization of our search keywords in order to determine the different types of searches being performed. We can do so using a cluster dendrogram. And what this diagram shows us is how all of the search terms are clustering together. And this is another great example of the types of functionality that R can provide that you're not going to be able to do when you're just using the SiteCatalyst user interface. The Q-trended function corresponds to the trended report within SiteCatalyst. Here you can see a search keywords natural report for the top 5 keywords over the February 1st to March 18th time period. To get the same trended report within R, we can submit the following function call to the Q-trended function. The main difference between using R and using the SiteCatalyst UI is that we're not going to be limited to just the top 5 trended words. And you can see with the top argument in this function, we're actually going to be able to get up to 100,000 keyword terms and have those terms trended in a single data frame from the time period of February 1st to March 18th. So you can see that this provides a significant improvement to the functionality from the SiteCatalyst user interface. Now, because I'm downloading so many keywords, this report is going to take quite a bit of time to return. Now that our function has returned an answer, we can see that we get back a data frame that has approximately 43,000 observations. And when we take a look at this data frame, you can see that we've downloaded literally hundreds, if not thousands, of search keywords, and we have the visits trended over the time period that we requested. So this is a great way to get a lot of data out of SiteCatalyst so that you can use it in further analyses. If you're perhaps an SEO that's trying to monitor different keywords over time, you're no longer going to be limited to just the 5 keywords per report that you would get within SiteCatalyst. Here you can actually download the entire set of keywords and then do your analysis. Now, because I've returned so many results, I'm actually not going to do a visualization with the search keywords. I actually have a second example here where I've outlined some browsers that I'm calling the antique browsers. So your Internet Explorer 6, 7, some AOL browsers, Safari I believe is in version 5 or 6 now, Google Chrome is in its 20s. We've already returned an answer here. So the next thing that we can do is just do a simple line plot for the different browsers And what we can see here, again, is R provides a way of getting functionality that's not present within SiteCatalyst. So here we have a report that has 7 trend lines. You can only see a couple of them because most of these browsers have no visits to my website. But what this provides is a way to improve the analysis that you're doing in getting around some of the limitations of SiteCatalyst. In a video like this, it really isn't possible to cover all functionality present in the RSiteCatalyst package, as well as all of the potential use cases. In addition, it's likely that new functions will be added to the package and bug fixes made as they arise. I encourage anyone interested in using this package to visit the Keystone Solutions blog and my personal website at randyswitch.com to get more information about the RSiteCatalyst package.